Hello guys, today we will see how to create metal bending effects in Houdini using RBD, glue and soft constraint. And this is extremely stable simulation. As you can see, there is no jitter and all. So let's dive into Houdini and see how to create this. So first take a geometry node and let's dive into it. Let's take a grid node and set the orientation to YZ plane, and here take a poly extrude node. Let's extrude it by very less distance. We need to extrude it, something like 0.1, and turn on output back. Now take a match size node and change the justify to minimum in a y-axis. Now this is our metal sheet. Let's fracture it using Voronoi fracture. We are not using boolean because if we want to do metal, then Voronoi is the best method. So take a Voronoi fracture and connect this to here, and we need to increase more fracture count. So let's keep the force total count to 2000. Now we will have small pieces. Now take a null node and name it as fracture.
Here, I will show you an awesome tool developed by my friend Henry. It eases the workload and has a lot of great features. In this tutorial, I will be using RBD Sim. With this tool, if I go to Effect GT, Rigid Bodies and select Quick Rigid Bodies, it will quickly create all the basic nodes for me. If I want to add a constraint, I can easily do that using this tool as well. For example, if I want to add a glue constraint, it will ask for my DOP network name. Once I select it and hit OK, my basic RBD setup is ready in just a few clicks. Now, suppose I have to render this node. I can select the node, right-click it, and choose Create Render Node from Selected. This will create a render node for me at the OBJ level. By default, this node has velocity blur turned on, and the display flag is set to nothing so the viewport won't be heavy if you are working on large-scale FX. However, it will render the actual FX. If I have many nodes and want to add a prefix or suffix to them, this tool will save a lot of time. Just click on prefix/suffix, type what you want to add, and it's done. There are also tools for merging nodes. You can save projects, create directories, and manage projects properly, all within a single tool. Additionally, it has many other features like quick instance, camera fog, camera focus, and much more. There is a free version available, so check it out. If you like it, consider buying the full version. The link is in the description.
I will name this as a fracture piece, and now I will go in this screenshot and I will choose effect rigid body, quick rigid body. So it will create the RBD DOP network, active pieces, everything. It will create by its own, and it will save few minutes of me. And if there is a tight deadline, this tool can help you out amazingly. I have been using this older version from 1 years. So currently this make all the pieces active, and I want the bottom part to get inactive. So to do this I will type if at p dot y is less than threshold chf threshold I at active is equal to 0, and I will click on plus icon and I will increase the threshold. Let's check which pieces are active and which are inactive. So I will type at active is equal to 0, and here we have to choose points. So okay, this is reverse, we have to put smaller. So yeah, so these pieces are inactive, we have to increase it more. Okay, cool. Now we need to add constraint as well. So to do that, there is also one tool. So let's select the assemble node and go in clean sort, go in effect, rigid body simulation, and click on RBD constraint menu. Currently it support only glue, hard, and spring. So we need two constraint, glue and soft, and soft will be added in the next version, I guess. So click on add glue constraint and it will ask to choose DOP network. So my DOP name is RBD sim. Will select it and I will press accept. So this is my constraint network, and I will close it. As you can see here, this will add a constraint node, glue constraint, everything. I will connect it here. Once the glue is broken, we need to switch it to back to soft constraint. So I'm not going to use this, but most of the time this is useful. So I will take a constraint properties node. I will connect it here and this will go in here. And one more thing here, the max connection it set to 5. I will choose the connection type to adjacent pieces from surface point, and I will make it default, and we have to turn on this length attribute, and the length name will be rest length only. And here we have to choose glue, and we have to turn on this switch constraint enable, and we have to choose soft only. And here in the strength, let's keep it to around 700 and turn on strength variance, keep it to 0.5, and rest everything is fine. And here in the soft constraint, set the stiffness value to 15 and damping to 5. Here in the glue constraint, since we are doing the strength and everything on the shop, here we have to keep the strength and every value to 1, and here in the data glue we have to type G capital. Now our constraint has been loaded. As you can see here, the red lines are our constraint. If anything is wrong, then you won't see any constraint on the DOP network. And if I play this, this is not falling down. Now we need to add a soft constraint as well. So connect merge node and take a soft bullet soft constraint relationship and keep everything default here. We need to set the stiffness value to 1, since we are setting this strength and all the values on the shop level. Now we need some balls to get hit on this metal sheet. So copy this mesh size node and paste it here. Instead of poly extrude, we will connect it to grid, and let's take a transform node and transform it around something like here. Now we can take a scatter node, we need only 1 point, and we will change the global seed to $f. So on each frame the point position will get changed. Here we will add a sphere node, and we will copy to point it on the points. So take a copy to point node. Now you can see this will look something like this. Now we need to add some noise, so take a attribute noise node, and we need to add on a position. Let's keep the range to 0 centered and reduce the amplitude, and we can turn on animation, so on each frame it will get changed. Like, okay, let's turn off animation and we will use offset. We can type $f here, so on each frame there will be a kind of noise pattern. Now you can see this will look something like this. Now we can take a assemble node and pack it, so we can feed this in DOP network. Make sure to change the output prefix to, let's keep it bullet, or else the name conflict will happen, since this our piece name is also piece 1 2 3 4 and so on, and this will also the same thing, so we have to avoid it. Now take a point velocity node, we need to add some velocity here, and in the initialization method set, let's keep it to keep incoming, and let's check the direction on which direction we need our velocity. So it will be on x, negative x direction, so let's keep it here 20, minus 20, and we need to make it active, so let's take attribute triangle and set I@active is equal to 1, and let's take a null node here. Cool. Let's name this bullet. So copy this null node, go inside the RBD sim and take another merge node. Let's duplicate this RBD pack object and connect it here. Here in the sub path we will give our bullet path, and if I turn on this, you can see currently it is not emitting on every frame. So to emit on every frame, we have to break this channel and write $f here. Now if you see, it will emit on each frame, but the issue is as you can see, this is already getting deformed, but this simulation is not very stable right now. We have to do some few tweaks using SOP solver. First, let's emit this bullet on every 5th or 10th frame. So to do this, take a switch node here, add a null, and here we can type $f%5 is equal to 0. If you want to emit on every 10th frame, then write 10 here, or you can see we have to keep our emitter on the second input. Now you can see on every 5th frame it will get a trigger. Now if we go in simulation, you can see on every 5th frame the bullet is getting emitted. Currently the size is too big, and it is same. So let's add a attribute adjust float, and we have to add some randomization on a p scale value. Here we have to keep random, and let's keep it to 0.5 to 1. Now it will have some variation in it, and also let's keep it to around 0.75. Now let's again go and see how this looks. Yeah, cool. I think it is too small right now. Let's make it to 1, uniform scale to 1. Yeah, now it is fine. Now take a SOP solver and connect it to constraint third input. Dive inside it. We have to use this relationship geometry here, so connect this here. Now take a attribute wrangle, make sure to change this to primitive, run over type to primitive, and here we have to write a small code. I will make it bigger. So if constraint name is equal to glue, I@timer is equal to 0. Else if s@constraint name is of to I@timer is equal to plus is equal to 1. So what it will do, if the constraint name is glue, as you can see here, when the ball is not get hit on the plate, it is red. Means the red means our current constraint is of glue constraint, and whenever the bullet hit the plate, the constraint get changed to white. It means the white are the soft constraint. If I go in spreadsheet and if I show you a relationship constraint, and here I will choose geometry and I will go in primitive, you can see the constraint name are glue, and there will be few constraint which will be the soft constraint. So what this code is doing, if the constraint name is glue, then the timer attribute will have the value of 0, but if the constraint name is soft, then the timer will get additional plus value on each frame. So once the constraint change to soft, then the timer value keep increasing on every frame. Like on first frame it will be 1, then on the next frame it will be 2, 3, 4, 5, and so on. So what we need to do with this, so we will give one statement. If the timer value is timer greater than 1 and at group broken is equal to 0. As you know, the soft constraint don't get broke by itself as compared to glue. If anything hit on the glue constraint, then the glue directly get broke and the piece will get fall down. But in the case of soft constraint, it won't get broke. It will keep getting stretched, or it will keep hanging along with the other pieces, but it will not get broke. We have to broke it manually using some code or anything. So here I have given one condition. If the timer value is greater than 1 and the group is not still broken, then constraint name is equal to glue. Since we have to give 3 4 value, let's add a curly bracket here, and we will reset the timer as well. Timer is equal to 0, and whenever again the ball gets hit on the same place, it should turn into glue again. So to do that, there is a one attribute called next constraint name. If I go in RBD constraint properties, currently it is glue constraint, but there will be one attribute called, if I so here you can see next constraint name. If I go in here primitive, you can see our current constraint name is glue, but the next constraint name is soft, because mm, if the glue is broken, then this constraint will get take place. So here also we have to do the same thing. Set the rate next constraint name is equal to soft, and set the rate next constraint type is equal to all. Let's close the bracket, and okay, there is some problem. We have now, if I see, if I play this, as you can see here, if this ball get hit, mm, this area is a soft now, but after few frames all this area will get turn into glue again. As you know, the soft constraint are not still very much stable. We have to do a lot of things to get it extremely stable. Here, to avoid the jitterness, I have switched it back to glue, so it will look like this. Now if I turn on this geometry, you can see this will look like this. And let's increase this velocity to around 30. Here we can do a few things. Let's keep this strength value to 500, and the strength variation to, let's keep it 0.2. Now go in RBD sim. Here we have to change this bullet data. Go in bullet data tab and turn on this create convex hull per set of connected pieces. Turn on show guide geometry, and here we have to set the collision padding value to 0.0002. Now if I play this, go in solver, and here we have to also give the glue constraint type to all. Set the rate constraint type is equal to all. uh, as you can see, there is some issue, like if this ball get hit, then it is retaining its position. So to fix this, what we can do, we can reduce the half-life value, and it should be on the glue constraint, and we have to keep this to 0.1. So what does this half-life do? It dissipate the forces. Now if I play this, it will look like this. Yeah, so you can see now our pieces are getting retained, but these pieces are getting stuck over there. But no problem, let's increase this piece scale value. So now let's play this. Twenty is making it to stick. Let's keep it 15, and let's cache this out. We have to delete this since we have to use RBD point deform pieces. So take a DOP import node, and we have to select DOP network here, and we have to import RBD object 1. This will import only our metal piece, and we have to duplicate this, and here we have to import our constraint network. So currently the constraint network won't get deformed. We have to deform it using transform pieces node. So here take a time shift and freeze it to first frame, and take a transform pieces node, connect DOP import to first frame, and DOP import 1 to second, and the time shift will go on third. Now you can see our constraint has been deformed. It will look like this. Now we can take a RBD deform pieces node, connect this here and the constraint here, and this will again go in here since we don't have any proxy pieces. Here in the boundary connection, select constraint. Now you can see our this has been deformed. Let's set the maximum to now. You can see our metals are getting deformed. Let's take a file cache node and set the deform. Now take a null node. Now we need to import our balls also, so take RBD object 2 and let's merge both of them and create a play blast. So this is our stable metal deform simulation. If you like this tutorial, then you can hit the like and subscribe button. You can also support me on Patreon, so I will keep bringing new awesome tutorials for you, and you can use this method to create car destruction or something like that. So thank you guys for watching. See you in the next tutorial.